Welcome back to our channel Amana Study Center. In previous class we have almost completed the complex number. Only the miscellaneous example and exercise have been left. Today we will practice the miscellaneous example and solve all the miscellaneous problem of your NCERT textbook. We will learn with enjoy. Without that the learning is not successful. Okay, so let's enjoy our class. Let's look at the question. Example number 1. Find the conjugate of 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus I. So we first simplify this. Okay, so here 3 minus 2i, 2 plus 3i divided by 1 plus 2i into 2 minus I equal to z left. Okay, so therefore equal to, just simplify this. Okay, we have simply multiply 6 plus 9i minus 4i minus of 6i square. Okay, here 2 minus I plus 4i minus 2i square. Okay, equal to, here what will we find? Here I square equal to minus 1, therefore 6 plus 6 we can write, and here will be the 5i. Okay, and here 2 I square minus 1 plus 2, 2 plus 2, and here plus 3i. So we have 12 plus 5i divided by 4 plus 3i. Just rationalize this. We get 12 plus 5i into 4 minus 3i divided by 4 square minus 3i whole square. Okay, therefore we have just multiply both 48, okay, minus 36i plus 20i minus of 15i square. Okay, 16 plus 9. Okay, therefore we have 15i square mean plus 15 minus 15i square mean plus 15. So 48 plus 15 equal to 63 minus of 16i divided by 25. So this can be written as 63 by 25 minus 16 by 25i. Okay, so this is the value of z. So now conjugate of z equal to z bar. So here we write the real part first 63 25 and write the imaginary part 25i. Then the sign between them here minus. So here will be the plus. This is the answer. Okay. Let's look at this question. If x plus iy is equal to a plus ib divided by a minus ib, prove that x square plus y square equal to what? So we have x plus iy equal to a plus ib divided by a minus ib. Just rationalize this. We get a plus ib into a plus ib, and here a minus ib into a plus ib. Okay, just a plus ib whole square, and here a plus b, a minus b formula, a square minus ib whole square. So we have a square plus I square b square minus, sorry, plus 2abi. Okay, and here a square plus I square b square equal to minus b square, and minus minus will be plus, a square plus b square. So we have a square minus b square divided by a square plus b square plus I of 2ab divided by a square plus b square. Therefore here xy equal to this. Therefore we get x equal to a square minus b square divided by a square plus b square, and y equal to 2ab divided by a square plus b square. Comparing the real part and imaginary part we get. Okay, here you should write comparing the real part and imaginary part we get. Okay, then now we have to prove x square plus y square equal to 1. So LHS equal to x square plus y square. Okay, now put the value of x and y. We get here the value of x is equal to a square minus b square by a square plus b square. So a square minus b square divided by a square plus b square whole square plus y equal to 2ab by a square plus b square. 2ab by a square plus b square. whole square. So now simplifying this, we get a square plus b square, the LCM of this, and here a square minus b square whole square plus 4a square b square. Okay, this is the formula of a square plus b square whole square, and this is will be same. So these two will be cancelled, therefore 1 equal to RHS. Proved. Okay. Now we will solve the miscellaneous problems of your NCERT textbook. Okay, just look at the question. Question number 1. Evaluate I to the power 18 plus 1 by I to the power 25 whole cube. So just we have I to the power 18 equal to I square to the power 9. Okay, plus 1 by I to the power 25. Okay, whole cube. I square equal to minus 1 to the power 9 plus 1 by I to the power 25. Okay, whole cube. Therefore we have here minus 1 and here 1 by I to the power 25 means I square to the power 12 into I whole cube. Therefore we have minus 1 plus 1 by I square means minus 1 to the power 12 equal to 1. That means this is I whole cube. Okay. So minus 1, just rationalize this, we have I divided by I square cube. So we have minus 1 minus of I whole cube. Just apply the formula of a plus b whole cube. So we have minus 1 whole cube plus 3 minus 1 whole square dot I, minus I, okay, plus 3a minus I whole square plus minus I whole cube. Therefore we have minus 1 and this is the minus 3I, this is minus 3 I square means minus 1 plus of minus I cube, that means I square dot I. Okay, so we have minus 1 minus 3I plus 3 minus I square means plus 1, that means this is plus I. So we have 2 minus 2I. Okay, this will be the answer. Then look at this question. For any completion of Z1 and Z2, prove that real Z1 dot Z2 equal to real Z1 dot real Z2 minus imaginary Z1 dot in Z2. Okay, so we first let Z1 is equal to A plus IB, Z2 equal to C plus IT. Okay, therefore if Z1 is equal to A plus IB, then RE Z1 equal to A and imaginary Z1 equal to B, and here real Z2 equal to C and imaginary Z2 equal to D. Okay, then now Z1 dot Z2 equal to simply multiply. That means we should apply the formula of multiplication. Therefore we have AC minus BD plus I of CB plus AD. Okay, Z1 Z2 here. Now the RE Z1 dot Z2 equal to the real part of Z1 Z2, that means this equal to AC minus BD. Here A equal to real Z1 and C mean real Z2 minus B equal to imaginary Z1 and D equal to imaginary Z2. Okay, so very easy. Now look at this question. Reduce 1 by 1 minus 4i minus 2 by 1 plus I into 3 minus 4i by 5 plus I to a standard form. That means A plus IB form. Okay, so we have just simplify that. First LCM between these two, 1 minus 4i into 1 plus I. Therefore here 1 plus I minus 2 minus plus 8i. Okay, just apply second bracket, and here will be the same 3 minus 4i divided by 5 plus I. Now we have 1 plus I minus 4i minus 4i square, and here will be minus 1 plus 9i. Okay, so and this will be the same 5 plus I. Okay, just multiply this. We have, just look here, 4 plus 5 minus 3i, and here I plus I, and here minus 1 plus 9i, and 3 minus 4i. Just multiplying, we have minus 3 plus 4i plus 27i minus 36i square, and here 25 plus 5i minus 15i minus 3i square. Therefore we have 36 plus 36, therefore 33 plus 31i, and here 28 minus 10i. So just rationalize this, we get 33 plus 31i into 28 plus 10i. Okay, and here 28 square minus 10i square. Okay, therefore now here we get 33 into 28 means 924 plus 330i plus 3128 means 868i, and here 310i square, and here will be 20 square means 784 plus 100. That means therefore we have okay. Now equal to 307 by 442 plus 599 by 442. This will be the answer. Okay. Look at this question. If x minus iy equal to root over a minus ib divided by c minus id, prove that x square plus y square whole square equal to a square plus b square by c square plus d square. So now by here we can write x minus iy equal to root over, just rationalize this, we get c square plus d square divided by a minus ib into c plus id. Okay, by squaring both we get x square minus y square minus 2xyi equal to ac plus iad minus ibc minus plus bd divided by c square plus d square. Okay, therefore this part will be AC plus BD plus I of AD minus BC divided by C square plus D square. Now comparing both sides, we get x square minus y square equal to AC plus BD divided by C square plus D square. Okay, and minus of 2xy equal to AD minus BC divided by C square plus D square. Okay, now here LHS equal to x square plus y square whole square. That means this can be written as x square minus y square plus 4x square y square. Okay, this can be written as in this type. Now putting the value of this AC plus BD divided by C square plus D square plus 2x square. The square means AD minus BC divided by C square plus D square whole square, and here will be the whole square. Now just solve this, we can get C square plus D square whole square, and here A square C square plus B square D square, and here the minus of 2 ABCD and plus of ABCD will be cancelled. So we can write this as A square D square plus B square C square. Therefore the A part A square C square plus D square will be common between these two, and here common D square C square plus D square and divided by C square plus D square whole square. Therefore we have C square plus D square into A square plus B square divided by C square plus D square whole square. Now cancelling C square plus D square, we have A square plus B square divided by c square plus d square equal to RHS proved. Okay. Then look at this question. If Z1 is equal to 2 minus I, Z2 is equal to 1 plus I, find Z1 plus Z2 plus 1 divided by 1 minus Z2 with Z1 plus Z2 plus 1 whole mod. Okay. So we first find Z1 plus Z2 plus 1 equal to just putting the value 2 minus I plus 1 plus I plus 1. That means this will be 4 and I will be cancelled 4. And Z1 minus Z2 plus 1 equal to Z1 means 2 minus I minus Z2 minus 1 minus I and plus 1. Plus 1 minus 1 will be cancelled and here 2 minus 2I. Okay. Now Z1 plus Z2 plus 1 divided by Z1 minus Z2 plus 1 equal to 4 divided by 2 into 1 minus I. Just cancel this, we get 2 1 minus I. We get 2 into 1 plus I and here 1 square minus I square. Therefore 2 by 1 plus I by 2. 2 will be cancelled, therefore 1 plus I. So now mod of Z1 plus Z2 plus 1 divided by Z1 minus Z2 plus 1 equal to root over 1 square plus 1 square. That means root 2. Okay. Then look at this question. If a plus ib is equal to x plus I whole square divided by 2x square plus 1, prove that a square plus b square equal to x square plus 1 whole square divided by 2x square plus 1 whole square. Okay. Now we first do a plus ib equal to just squaring this x square plus I square plus 2xi and here will be 2x square plus 1, or a plus ib equal to x square minus 1 plus 2xi divided by 2x square plus 1. Now comparing the real part and imaginary part, we get a equal to x square minus 1 2x square plus 1 and b equal to 2x divided by 2x square plus 1. Okay. This equal to x square minus 1 divided by 2x square plus 1 plus I dot 2x by 2x square plus 1. LHS equal to a square plus b square equal to, just put the value of a and b. That means x square minus 1 divided by 2x square plus 1 whole square and b equal to 2x by 2x square plus 1 whole square. Now LCM between these two we get x square plus 1 whole square and here just squaring the both. No need to square that, just write x square minus 1 whole square plus 4x square. This is the formula of x square plus 1 whole square divided by 2x square plus 1 whole square equal to RHS. So, okay. Now look at this question. If Z1 is equal to 2 minus I and Z2 equal to minus 2 plus I, find real Z1 Z2 by Z1 complement and imaginary 1 by Z1 complement. This is the Z1. Now for 1 we first find out Z1 and into Z2. That means 2 minus I into minus 2 plus I. Just multiply this, we get minus 4 plus 2I plus 2I minus of I square. That means minus 3 plus 4I. Okay. And Z1 bar equal to 2 plus I. Okay. Now Z1 by Z2 by Z1 bar equal to minus 3 plus 4I divided by 2 plus I. Now rationalize this, we get minus 3 plus 4I into 2 minus I divided by 4 minus I square. That means minus 6 plus 3I plus 8I minus 4I square divided by 4 plus 1 equal to 6 plus 4, that means minus 2 plus 11I divided by 5 equal to minus 2 by 5 plus 11 by 5I. So now RD Z1 Z2 divided by Z1 bar equal to the real part, that means minus 2 by 5. And for this 2 we have Z1 bar equal to 2 plus I and have Z1 equal to 2 minus I. Now Z1 dot z1 bar equal to 2 plus I into 2 minus I. Therefore we have 4 minus I square, that means 4 plus 1 equal to 5. Now 1 by z1 bar equal to 1 by 5. Now equal to, this can be written as 1 by 5 plus I dot 0. So imaginary 1 by z1 bar equal to 0. Okay. Let's look at this question. Find the real number x and y if x minus iy into 3 plus 5y is the conjugate of minus 6 minus 24i. We first find the conjugate of this. So conjugate of minus 6 minus 24i is equal to minus 6 and 24i. Here the sign between these two will be changed. That means this. Now simplify this, x minus iy and 3 plus 5y. We get 3x plus 5xi minus 3yi minus 5y I square. So we have 3x plus 5y, and here if we common I, 5x minus 3y. And this value, as this value is equal to this value, so we have 3x plus 5y plus I into 5x minus 3y equal to minus 6 plus 24i. So just comparing these two sides, we get 3x plus 5y equal to minus 6. This is equation number 1, and 5x minus 3y equal to 24. This is equation number 2. Just solving this, we get here 5, here 3. We get 15x plus 25y equal to minus 30, and here 15x minus 9y equal to minus plus 72. Therefore minus plus, this one will be minus, therefore this will be cancelled, and here 34y equal to minus 210. Therefore y equal to minus of 102 by 34. Therefore 217, 251, 3. Therefore minus 3. Now putting the value of y in equation number 1, therefore x equal to minus 6 minus means this is plus 5 dot 3 equal to 15 divided by 3. That means 9 by 3 equal to 3. So x equal to 3 and y equal to minus 3. Then look at this question. Find the modulus of 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. Just simplify this, we get 1 minus I into 1 plus I, and here 1 plus I whole square minus 1 minus I whole square. So a square minus b square. So we put a plus b into a minus b, and here a plus b into a minus b, that means I square. That means here I will be cancelled, and here 1 will be cancelled. So 2 dot here 2i, and here 1 plus 1. That means 2 dot 2i divided by 2. 2 will be cancelled, therefore 2i. Okay. So this can be written as 0 plus 2 dot I. So the mod of 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I equal to root of 0 square plus 2 square. So we have 2 square, that means 2. Okay. Then look at this question. If x plus iy whole cube equal to u plus iv, prove that u by x plus v by y equal to 4 into x square minus y square. We first simplify this equation. Okay. Therefore we have x cube plus 3 x square dot iy plus 3 x dot I square y square plus I cube y cube equal to u plus iv. Okay. Or x cube plus 3x square yi I square equal to minus 1, that means 3x y square, and here minus y cube I equal to u plus iv. Or segregating the real part and imaginary part, we get x cube minus 3x y square plus I into 3x square y minus y cube equal to u plus iv. Now comparing the real part and imaginary part, we get u equal to x into x square minus 3y square, and v equal to y into 3x square minus y square. Okay. Now LHS equal to u by x plus v by y. Just putting this value, we get x into x square minus 3y square divided by x plus y into 3x square minus y square divided by y. By cancelling this x and y, we get x square minus 3y square plus 3x square minus y square equal to 4x square minus 4y square equal to, if we common 4x square minus y square equal to RHS equal to proved. Okay. Now look at this question. If alpha beta are different complex number with mod beta equal to 1, and then find mod of beta minus alpha divided by 1 minus alpha bar beta. Let's see. Let alpha equal to a plus ib. Okay. And beta equal to I or 1. Only 1. Okay. Why? Then look. Here beta equal to I or 1. So beta equal to, when beta equal to I, then this can be written as 0 plus I dot 1. So here mod beta equal to root over 0 square plus 1 square equal to 1, and when beta equal to 1, then this can be written 1 plus I0. So mod beta equal to 1 plus 1 square 0 square equal to 1. So beta can be any of these two. Okay. So now beta minus alpha equal to, so beta, let beta when beta equal to 1. Okay. Beta minus alpha equal to 1 minus a minus ib. Okay. And alpha conjugate of alpha equal to a minus ib. Okay. Now 1 minus alpha dash beta equal to 1 minus a minus ib, beta equal to 1. So this will be the 1 minus a plus ib. Okay. Now beta minus alpha divided by 1 minus alpha dash beta equal to 1 minus a minus ib divided by 1 minus a plus of ib. Just rationalize this, we get 1 minus a minus ib into this, that means this is whole square, 1 minus a whole square minus I square b square, that means plus b square. Okay. Now applying the formula, we get 1 minus a whole square minus of b square minus of 2 1 minus a dot bi. Okay. Divided by 1 minus a whole square plus b square. Okay. So now separating the real part and imaginary part, we get 1 minus a whole square minus b square divided by 1 minus a whole square plus b square plus I of minus 2 1 minus a dot b divided by 2 1 minus a whole square plus b square. Now mod of beta minus alpha 1 minus alpha bar beta equal to square root of 1 minus a whole square minus b square divided by 1 minus a whole square plus b square whole square plus 2 of 1 minus a b whole square divided by 1 minus a whole square plus b square. Okay. Just solve this, we get here 1 minus a whole square plus b square whole square total and here we will get 1 minus a to the power 4 plus b to the power 4, and here minus 2 square and here 4, that means plus 2 1 minus a square b square, and this is the formula of this, and by and here we will get 1 minus a square plus b square. Okay. Whole square divided by 1 minus a whole square plus b square whole square. Okay. And these two will be cancelled, therefore root of 1 equal to 1. Okay. So mod of this value will be 1. We get this value when beta equal to 1, and when beta equal to I, the value will be the same. Okay. When beta equal to I, you will solve this equation. This is your homework. Okay. Just look at this question. Find the number of the non-zero integral solution of the equation mod of 1 minus x to the power x equal to 2 to the power x. Okay. We first find mod of 1 minus I equal to root of 1 square plus minus 1 square equal to root of 1 plus 1 equal to root of 2. This can be written as 2 to the power half. Okay. Now mod of 1 minus I to the power x equal to 2 to the power x. Here we get mod of 1 minus I equal to 2 to the power half, or 2 to the power half to the power x equal to 2 to the power x. Now simplifying this, we get 2 to the power 2 x by 2 equal to 2 to the power x. Now therefore we get x by 2 equal to x, or 2x minus x equal to 0, or x equal to 0. Here 0 is the integer, so there is no non-zero integral solution. Okay, therefore there are no non-zero integral solution. Okay, look at this question. If a plus ib into c plus id into e plus if into g plus ih equal to a plus ib, so that a square plus b square into c square plus d square into the e square plus f square plus g square plus a square is equal to a square plus b square. Just here apply the formula of multiplication. Okay, we get here AC minus BD, and here CB minus AD, sorry, plus I of CB minus AD. Okay, this is the value of this, and this is the value of EG minus, this is the plus EG minus FH plus I of GF plus EH. Okay, equal to a plus IB. Now just multiply this 2, we get AC minus BD into EG minus FH, okay, plus I of AC minus BD GF plus EH, okay, plus, now I am mix the 2, we get CB plus AD into EG minus FH, okay. This is the part of I, plus of, that is, this will be minus, that means I square, CB plus AD and GF plus EH, okay, equal to a plus I. Therefore A equal to AC minus BD into EG minus FH minus CB plus AD into GF plus EH, okay, and B equal to the I part, that means AC minus BD GF plus EH plus AB plus CB plus AD into EG minus FH, okay. Now just a square plus b square, that means just let RHS equal to a square plus b square. Now putting the value, now a square equal to b square will be AC minus BD whole square EG minus FH whole square minus 2 of AC minus BD EG minus FH plus CB plus AD whole square into GF plus EH whole square, and b square equal to AC minus BD whole square GF plus EH whole square plus 2 of AC minus BD here also to CB plus AD, and here with 2 GF plus EH, okay, and here also GF EH plus EH into CB plus AD EG minus FH plus of this part CB plus AD whole square into EG FH, okay. Now if we plus this minus 2 plus 2 this part will be cancelled. Okay, and here we have only a square plus b square equal to AC minus BD whole square. If we common this, we get AG minus FH whole square plus GF plus EH whole square. Okay, and here if we common this to CB plus AD whole square, we have GF plus EH whole square plus AG minus FH whole square. Okay. Now I removing this. From here I can write this a square plus b square equal to, now the common element is this. That means if we common GF plus EH whole square plus EG minus FH whole square, and there will be AC minus BD whole square, and here will be CB plus AD whole square. Okay. Now simplifying this, we get G square F square plus E square H square plus 2 EFGH plus E square G square plus F square H square minus 2 EFGH. Here A square C square plus B square D square minus 2 ABCD, and here C square B square plus A square D square plus 2 ABCD. Now cancelling this and cancelling this, we get here if we common G square F square and between these two common H square E square plus F square. Okay, and here A square common C square plus D square, and plus here these two B square if we common C square plus D square. Okay, now from these two E square plus F square if we common, then there will be G square plus A square, and here C square plus D square, and there will be A square plus B square. Okay, equal to LHS. Okay. This question, if 1 plus I divided by 1 minus I to the power m equal to 1, then find the least positive integral value of m. So we first rationalize this. Okay, 1 plus I 1 minus I to the power m equal to 1, or here 1 plus I whole square 1 square minus I square to the power m equal to 1, or 1 minus 1 square plus I square plus 2I divided by 2 to the power m equal to 1, or 2I divided by 2 to the power m equal to 1, or I to the power m equal to 1. That means, or I to the power m equal to I to the power 4. Okay, only the value of I to the power 4 is 1. So by this we can write, therefore m equal to 4. So the least positive integral value of m is equal to 4. Okay, that's all for today's class. If you like this video, then don't forget to subscribe our channel. If you subscribe our channel, then you will get all the latest content uploaded by us. Thanks for watching our video.